No? Okay, let's try another one. Okay, so there's our matrix. That's A. What's C going to be equal to? Well, C is going to be equal to 3 and 4. Yes? 0 minus 5. That's a minus 0, but we don't really care. So C transpose, which is adjoint A, is going to be 3, 4, minus 5, 0. Okay? Are we good there? What's the determinant of this? So come back to A. What's the determinant of A? Is going to be 4 times 3 minus 0 times 5, which is 12, right? Yeah? Yeah. Okay. So A inverse is going to be 1 over 12 times 3 minus 5, 0, and 4. So A inverse equals 3 twelfths minus 5 twelfths, 0, and 4 twelfths. Exciting? Okay. So that's A. This is A inverse, right? Which is 5 over 12, 4 over 12, and 0. And something's negative in there, that one. Okay, are we good? That's so beautiful. Is it not beautiful? It is beautiful. Now, take row versus column. Yes? So I take 4 times 3 over 12 plus 5 times 0. Row versus column. Okay? 4 times minus 5 over 12 plus 5 times 4 over 12. Then I go row. Let's do that in purple. How's purple? Row versus column, right? So I have 0 times 3 over 12 plus 3 times 0. And then row versus column. So I have, 0 times minus 5 over 12 plus 3 times 4 over 12. That's 1. That's 0. That's 0. And that is 1. So this is equal to 1, 1, 0, 0. It's equal to an identity matrix. It's an I. Yes? And that is the inverse of A. Oh, this is so nice. Is it not nice? This is nice. It not get no more nice than this. This is nice. It is nice. Is it not nice? It is nice. Nice. Now, we haven't done big old nasty like 3 by 3 anything. And yeah, we're talking big old nasty there. But let's go try something else. Okay, so we have two equations here, which I can put into matrix form, yes? By saying 2, 4, 3, minus 1, x, y, equals 28 over 0. Okay, I can do that, yes? That's a beautiful matrix formy thing. Yes? Okay. We call this matrix A, we call this matrix X, and we call this matrix D. This is a 2 by 2. This is a 2 by 1. That's a 2 by 1. Okay? Is that good? Just nod your heads, right? Even though I can't see them. That's beautiful. Now, AX equals D. But now I know something. Yes? I know I can find A inverse. So I multiply A inverse to both sides of my equation. Those two things become I. They go away. That's 1, right? So I get X equals A inverse D. Now that is a beautiful equation because now I can solve for X. I don't have to go here and do all this, solve for Y, stick Y in there, do all the algebra. I don't. Okay? And this not only works for a 2 by 2, it works for a 3 by 3, a 4 by 4, a 100 by 100, 1,000 by 1,000. We can use this to solve any number of equations and unknowns. Okay? You ready? You ready? You ready? All right, so A equals 2, 3, 4, minus 1. Yes? Yes? 2, 3, 4, minus 1. Did we already solve this? Two, 3, 4, minus 1. We already did this, right? Yes? And it's 1/14, 3/14, 4/14, and minus 2/14. So A inverse is plus 1/14. Go back. I'm already messing you guys up. 1, 3, 4, minus 2. Okay? So it's 1, 3, 4, minus 2/14. Right? 1, 3, 4, 2. Okay? Everybody excited by that? So now I have A inverse D equals 1/14, 3/14, minus 2/14, and 4/14 times 28 over 0. Pretty exciting? You're like, I could have done it the old-fashioned way. No, you can't. You're not old-fashioned anymore. 2 by 2, 2 by 1. I'm going to get a 2 by 1, right? So I start with row times column. All right? So 1/14 times 28 plus 3/14 times 0. And then row times column, right? Row times column. I get 4 times 4/14 times 28 plus minus 2/14 times 0. Okay? Which is, that's 2, and that's 8. So the solution to these equations is 2, 8. Well, let's find out. 2 and 8. 2 times 2 is 4. 3 times 8 is 24. 4 plus, 4 times 2 is 8, minus 8 is, yeah, that's the solution to this system of equations. Okay? Was that fun? Does it get more fun than this? Really, it doesn't. Okay? It really, really doesn't. This is about as fun as it gets. Actually, we're going to do something here in a minute, which is even more fun. Yeah? No? You're not believing me? Yes. We're going to do something that is even more fun than this because, yeah, fun. Fun? You're not buying fun? I'm buying fun. Okay? So, he said, so let's do another one. Shall we? Shall we? Yeah, let's do another one that we've already done. Right? 5x1 minus 3x2 equals 28. I don't know why I like 28s, but just live with it. Okay? Now we can turn that into an equation system, a matrix equation system. 5 minus 3 minus 2 and 4, x and y equals 28 and 14. Okay? That's A, that's x, that's D, that's a equals. Okay? So I have 5 minus 3 minus 2 and 4. That's A. Yes? C is going to be 4, 5, minus 3, minus 2. Yeah? Sorry, pluses. Right? Yes? Yeah? Adjoint A equals C transpose equals 4, 2, 3, 5. Okay? Yes? And determinant of A is 5 times 4 minus 2 times minus 3 is 20 minus 6 is 14. Are we good? Yes? So if we block this out, A inverse is 1 over 14 times 4, 3, 2, 5. Okay? Yes? So inverse A is 4 fourteenths, 3 fourteenths. And you're like, how come we're always getting 40? Because I do 2 fourteenths and 5 fourteenths. Okay? And if you're saying, sometimes you screw this up, I'm like, yeah, I do. And the advantage of being in class, the good part about being in class, is that it gives you guys a chance to figure out that I've just screwed it up, and you can yell at me, and all class long people are yelling at me like, hey, that was a 3, that's a minus, that's, okay? And so you're, yeah, okay? So that's adjoint A, that's inverse A, right? So what we're going to have, here's D. So x equals inverse A times D. D is 28 and 14. It's a vector, right? So x equals 414, 314, 214, 514 times, it's 28 and 14, right? 28 and 14. 28 and 14. So again, row times column, right? So 4 14s times 28 plus 3 14s times 14. Okay? And then again, row and column. 2 14ths times 28 plus 5 14ths times 14 equals, yeah, that's 8 and that's 3, so that's 11. And that's 4 and 5, which is 9. Pretty exciting? And 11 and 9 should be the answer. Okay? What did I do? Oh, there we are. Okay. This is so much fun, right? You're having so much fun. F-U-N, fun. F-U-N, fun. This is fun. Okay? Fun, fun, fun. Now there's another way to do all this. And you're like, I'm tired of this way of doing all this. But there's another way to do all this. And the other way is using something called Cramer's rule.